Men, and I use the term in the strictest sense of the meaning, we're going to truck on down the road of the manly art of welding Harley crankcases. If y'all remember from my previous video, this crankcase has a little problem. To wit, this chunk of crankcase is no longer part of the crankcase. And as much as I would kind of like to whip out my TIG torches and just zip that thing together right now, there's a little planning that goes involved with this, and we should discuss a few things. First of all, I said I believe that this was an 86, and once the crud is washed off it, there's a little more evidence of that. There was a Harley part number over here, 2455286. And Harley way of doing things, the last two digits of the part number is the year the part was first produced. So that would lead me to believe that this is probably an 86. The last year of the Ironheads was 85, so of course 86 would be the first year the Evo's got on new crankcases. There was also a date of manufacture, 8/19/85. So this was cast on August 19th, 1985, which would make it a very early 86. There's also a belly number right here, 313. The belly number is not on the belly. On the old engines, the belly number is on the belly, but on the modern engines, they're not. They're stamped over there. Here is the other belly number, also 313. So I've got no doubt that these were in fact a matching set of crankcases. There's some other numbers on here. There's this number, 1-886-239-006, which matches this number, 1-886-239-006. I don't know what that number is. I don't know what it means. I don't know whether it means anything. But the two numbers are the same. Once again, kind of making me believe these were a set of matching cases when they started life. A couple things to be mentioned while we're talking about Harley crankcases. For you guys that are obsessed with oil pressure, here's a couple of reasons why it doesn't matter. The main bearing, of course, goes in here, and it's a double row Timken bearing. There is no oil pressure supplied to the bearing. This bearing is oiled by oil that collects on the crankcase, dribbles down into this V groove, dribbles into this hole, and exits in this groove between the bearings and oils the bearings. It's drip feed. That's all there is to it. This hole over here is on the inside of the oil seal, and it directs the oil to the bottom of the crankcase where it collects in this sump. As the flywheel is spinning, the oil is scraped off into this cavity over here. Once in that cavity, it's picked up by this hole, which returns it back to the oil tank. Let's wait for the air compressor to quit running. Alright, men. Now that the compressor is done doing its thing, oil. Oh yeah. Directed to the bottom of the crankcase and gets sucked up by this hole here and directed back to the oil tank. The pinion bearing, of course, goes in here. There's no oil passageway provisions for oiling this thing at all. The only oil this thing receives is oil that's being splashed around in the crankcase. When the pistons are on their downstroke, it creates a great deal of air pressure in here, some of which is forced out of this hole to help the oil out. And the rest of the air that can't escape through here is directed in the clearance area around the bearings, carrying the mist of oil that's in the crankcase into the gear case cover, where of course it could be directed back to the oil tank when it's picked up by the scavenged side of the pump. In your trans, right up here is a little trough. In that little trough is a hole, and that hole comes out right here. The oil that collects in that trough and drips out in this hole is what lubricates the main shaft bearing. So Harleys use a lot of drip oil and unpressurized oil to lubricate bearings. That's the way they're designed. Works fine for the most part. Anyway, back to the crankcase. One of the things I do is I run a tamper die through all of the bolt holes before I put a crankcase together. Because the last thing you want to find out about is that you've got a stripped bolt hole when your crankcases are assembled and full of sealer and you're ready to bolt them together. That really cramps the style. So we're going to run a die, or a tap, excuse me, down through these holes and make sure they're clear all the way to the bottom. Thankfully there's not a lot of them, so you won't be bored to tears while I'm doing this. So there was a fair amount of crud in there. Since the last video, these things have been pressure washed, sandblasted, pressure washed again, and then scrubbed with soap and water. Just trying to get all the big nasty chunks off so that the welding will go smoothly. Hopefully it'll go smoothly. I've worked on a lot of Harley crankcases, but you know, I think this is the first Evo case that I'm going to weld on. Most of my welding is on the old ones because of course they need it. And for the record, a lot of guys, you know, they get a crankcase with damage like this and they say, well, I want to get a new set of crankcases. Well, if you got an Ironhead, there ain't no new crankcases around. If you buy a set of used cases, you know, they might not have a big chunk broken out of them, but I don't think I've ever seen a set of Ironhead cases that didn't have a bunch of cracks in them. Some bad, some not too bad. But you're not going to buy a set of pristine cases on eBay and expect them to bolt right on with no hassle. Those cases don't exist. Some guys say, well, I just need a right one or I just need a left one. Depending on what year you got, on some of them the VIN number's on the right side, on some of them the VIN number's on the left side. So you're going to have trouble with your Department of Motor Vehicles, I suspect, when you try to register that thing. Because if you put the one with the VIN number, now it won't match the VIN number on your frame, if your frame even has a VIN. And prior to 61, of course, they do not. The other you probably run into with swapping crankcase halves around, and I've swapped a few for people, you need to plan on at least running the lapping tool through the crankshaft bearings and the transmission main shaft bearing to draw them into alignment, or lap them into alignment if they're not. The other thing that I've run into is the holes for the piston skirts, the cylinder skirts don't always line up with one another. So you, in some cases, have to bolt the crankcase halves together, bolt them to a milling machine, and mill them out to get them to line up. I've also discovered that although Harleys are 45-degree V-twins, some are 45.5, some are 44.5, and the cylinder decks are not always even. Those could be matched up with hand filing, or once again bolt them in a mill and mill them out flat. For our purposes here today, you got just 3 more holes to check on. Let's see, what did I do with it? There it is. And then we'll move on to the next step here. These holes don't feel too bad. That one's got some crud in it. As long as we got this apart, a couple of words for you guys that like big bore strokers. You can see how little wall thickness you've got here that you're dealing with on this web between the cylinders. When you bore an engine out and you put big bore cylinders on there, you've got to bore the top of the crankcase. Well, there ain't no room to bore over here, or at least not much room to bore. What ends up happening is you have to take the bolt that goes in there and you have to neck it down in this area so that material is removed so the cylinder flange will clear. What happens is if you put the bolt in first and then drop your cylinder down, you won't be able to remove the bolt as long as the cylinder is in place, because the threaded part will be wider than the diameter of the bolt and it's effectively locked in. You can't pull it out. So you take a 5/16 bolt, you nick it down to maybe a quarter with 5/16 threads on one end. That's not very strong on something that you're planning on adding a lot of stress to. I wouldn't bore an engine unless I had to. I wouldn't bore an engine, expect it to be reliable for street purposes, because you're taking something that's not very well built in the first place and you're making it even scrawnier. Going back to the other side, let's clean the crud out of these holes. I like to use a blowgun that's got a little bit of a tip on it, because that gets to the bottom of the hole and blows the shit out. If you don't get to the bottom of the hole and blow the shit out and just stick an air nozzle in it, all you're doing is packing the shit in the hole even deeper. Good. And as long as we're talking about crankcases, these bolts here, I'm going to run a tap down through there. I'm not going to do that now. But one of the things I noticed that happens is people tend to use silicone on this gasket a lot. Well, they'll stick a bolt in there and they'll screw it in. Well, any silicone that was ahead of that bolt gets shoved into the bottom of the bolt hole. And this happens over and over again over the years. And eventually it will split this case, and you'll see longitudinal cracks running longitude parallel to the bolt, and this just splits open and the gasket shit starts oozing out of there because people cram it in there. So it's absolutely essential to avoid getting crap in those holes. And when you do take a primary cover off to redo these things, dig all the shit out of those holes. Make sure they're empty. Otherwise you're going to have a problem. This engine did not suffer that affliction. So let's get it ready to weld. We'll take our 2 halves. We're going to bolt them together. One more over here. You got to watch out on this bolt when you put your motor mount together. I ran into a case where a guy ran a bolt in here that was too long and actually punched a hole into the gear cover down here. I've seen some stupid shit working on these things. This bolt is almost too long, but not quite. And that's all that matters. Now for the fun one. Let's see. Alright, this is obviously the broken part. I'm going to tighten these 2 down. Of course I want this to be lined up with the crankcase. We're going to heat this all up in the oven. We're going to bake it probably about 350, 400 degrees for a couple hours, get it all up to an even temperature. If I tighten this bolt down as tight as it'll go, it's going to want to bend this thing and pull it out of alignment. That's probably not particularly critical because the counter shaft bearing bore is not contained within the crack part. But what I want to do to prevent that from happening is I'm just going to take a piece of welding rod and stick it in there so that when I tighten this down it'll pinch on the welding rod rather than bend the crankcase broken section and distort it. So we're going to tighten that up. I'll tighten this one up. That's good. If you recall from the previous video, I was able to slip a feeler gauge into this area here. So let's see what happens now. This is a 1/1000th feeler gauge, and it does not go into the gap at all. So if I were to successfully weld this without distorting anything, when I'm done and I bolt this back together again, or when I check it, I should not be able to slip a feeler gauge in there. That means, if I'm able to do that, that the case did not appreciably warp while it was being welded. And of course that's the goal, to keep it from warping while it's being welded. So I want to make sure these bolts are tight. They're good and tight. I've got a good gap all the way around so I could get some decent weld penetration in there. Let's make sure these bolts, I'm particularly concerned about these couple of bolts and these couple of bolts in this area here. You know, I'm going to be putting a lot of heat in this area, and that's why I'm concerned about it. Let's make sure these are tight. That's pretty tight. That's pretty tight. And that's pretty tight. Right now, I could take this thing over to my TIG welder and I could just zip along there and call it done. Not what I'm going to do though. Okay then, so what am I going to do? Let's talk about this little fucked up spot up here. There's probably at least a couple of 2 or 3 ways to fix this. One way would just be to build it up with weld, but I happen to have another cover, and man, that's a big gap in there. That's probably 1/2, 5/8 of an inch. It's going to take a lot of welding to build that up. So I think what I'm going to do instead is, I think I'm going to get some 3/4 inch rod, 3/4 inch aluminum bar stock, and just make a piece and then weld it all around. I think that's what I'm going to do to fix that. Here's my other problem. My argon bottle is down to about 500 pounds. I only keep one argon bottle on hand. I probably should get 2, but I only have one. I'd hate to start this and run out of gas a quarter of the way into it, because I know 500 pounds is not a lot, it's not enough to finish this. And I'd hate to subject this thing to unnecessary heating and cooling cycles. So I think what I'm going to do is get my bar stock, make my piece for this, throw this all in the oven, heat it up, weld this on, throw it back in the oven, drive into town, get my bottle refilled, come back with a full bottle, and then start welding the big crack. You have to have a little bit of a plan when doing this. If I just start welding here and weld all the way around like a guy might be tempted to do, what'll happen is the metal will expand and the crankcase is going to want to do this, and it'll warp the crankcase. So what I'm going to do is, I got a welding table that I could turn this thing upside down on the welding table. I'm going to turn it upside down. I'm going to weld a little bit over here. I'm going to weld a little bit over here, get as close to the seam as I can. Put about 1 inch here, about 1 inch here. I'm going to flip it so this side is up. I'm going to put about 1 inch here and about 1 inch here. I'm going to turn it back over, weld the rest of the way up to the corner, weld the rest of the way up to the corner, turn it back over, and then weld the rest of the way around. I think that'd be the most even way to do this and minimize the chances of the cases warping. But that'll be next time. So next time you see this, we'll be firing up the welder and we'll be going to town on it and hopefully get this project knocked out. Oh, just FYI, I do plan on welding the inside too. I would not consider this complete unless I welded both sides of the crack. The whole story of this is to get penetration as deep into the bottom of the crack as you possibly can. And the only way to do this for sure is to weld it from both sides. So I'm probably not going to be able to get all of it with the case halves bolted together, but I'm going to get as much of it as humanly possible with the case halves bolted together. I'll unbolt the case halves, finish the welding here, bolt it all back together again, throw it in the oven, bake it for about 350, shut the oven off, walk away, and come back in a couple of 2 or 3 hours after it's cooled off, take it out and see what we've done. At that point, there will probably be a little bit of welding at each end of this on the parting surface that I'll have to do, and I'll hit that with a little short quick bead while it's still warm maybe, and file it off, and hopefully that'll be all it takes. Anyway, I am out of here. See you when I get the torch fired up next time.